Good afternoon, everybody. Welcome to another sunny afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. Hi, everybody. I was looking at the syllabus earlier and we're on track, which makes me happy. I always try and keep on track with my syllabus. Plus, it helps you. All right. Now, don't forget, the lab you did last Wednesday is due today, and we'll do another lab today. It's an exciting lab. All right, where I left off last time, we were talking about aldehydes and ketones. Excuse me. Remember, an aldehyde, carbon, double bond to oxygen with an R group and a hydrogen on it, aldehyde. And there are different ways of drawing it, but I usually tend to draw it like this, or like this. Now you can draw it like this, either with or without showing the double bond, but I like this way only because I think it looks cooler. And good habits I don't break. Now the other functional group, and remember, I'm going to have way too much fun because Dr. White loves ketones and aldehydes, so does Mother Nature. Now, when you have a carbon double bond to oxygen with two R groups, and they can be the same or different, R and R prime, we call this a ketone. And you can draw it that way, which normally I'll draw something like this, or like this, or you can also draw it like this with the oxygen on top, or you can put a double bond like this. Remember, molecules rotate in 3 dimensions, just like your body does. And when we talk about ketones and aldehydes, I thought I cleaned everything up. Hang in there one sec. I'm having trouble with my, I don't know what. There. Now, the most important thing I know in organic chemistry, but that's personal, my opinion, is the carbonyl group. And you should know carbonyl group is carbon bond, double bond to oxygen. And you should know this. You should know how to write a carbonyl group and how to draw it. Oops, that's not what I want. And a carbonyl group, carbon double bond to oxygen, and you should know how to describe it with words and write it. And it's not a functional group, even though it's called a group, but it's found in many functional groups like ketones and aldehydes. And I went through this on Monday, but I'll just go through it again briefly. For an aldehyde, find the longest chain with the carbonyl carbon and name that as an alkane. Drop the E at the end and add Al. The carbonyl carbon is always number 1, and we never put that number 1 there because everybody knows it's number 1. And all other numbers and names for the substituents are, as you've already learned. So let's go try one. And the question would be, And for sometime in your future, you saw give the IUPAC name for A, why don't you go ahead and do it? Your turn. And thank you for all of you who are turning on your webcam, because that makes me feel like, hey, I'm looking at real people, not just names. And if you don't have a webcam, don't worry about it. Well, I think everybody's just about done. And we're all done. Let's do this. What's different? And now you should look at a molecule, look for what's not carbon, carbon single bond, or carbon or oxygen atom, hydrogen atom. And we have an oxygen there is double bond to carbon with a hydrogen. And our group, this is an aldehyde. And you find the longest chain, 1, 2, 3, 4. That's 4. 1, 2, 3, 4, 5, 6. 6 is the longest chain. That's hexane. Drop the E, add Al, hexanal. This is carbon 1. This is carbon 2. This is a T-butyl group. So it'd be T-butyl hexanal. Now, don't forget, the 6-membered ring, carbonyl, hydrogen. The IUPAC name is the common name, and this is benzaldehyde. And as you learned in our previous lab, it smells like maraschino cherries, or as I think of it, Dr. Pepper, and it also smells like almonds. Now, one of the things I'm always guilty of at Dr. White is I like to draw structures, but not too many words of writing out things. So when it comes to nomenclature, I usually draw more structures than names. On test number 2 and 3 too, but number 2 coming up, there'll be nomenclature questions. And there are 2 types of nomenclature question. The first one is give the IUPAC name for whatever. And the other one is draw the structure for. And why don't you draw the structure for 3-ethyl-4-methyl nonenal? We'll say that 5 times quickly. No, you don't have to. Well, where's the semester gone? We're already in week 6. It seems like just yesterday I was teaching you there's 4 bonds to carbon. And I still am. All right, I think everybody's done. So how do you decode this? You start from the right and move left. Al ending, aldehyde. And if that were an E, nonane is 9 carbons. And at the end, I like to do it this side. You could just as easily put it on this side, like the right. That's just my preference. Also, that's what my instructor in organic chemistry, when I learned, always did it, and I picked up his habit. So this is carbon 1, 2, 3, 4. On carbon 3, there's an ethyl group. Carbon 4, there's a methyl group. And now I'm going to start putting in hydrogens. And I'm done. And that's how you do that. Now let's look at ketones. And ketones, you find the longest chain or ring that, and this should have right there, or ring, which contains the ketone, meaning the carbonyl carbon, carbon double bond to oxygen. Name that chain or ring as per the IUPAC rules for alkane or cycloalkane. Now, drop the at the alkane or cycloalkane name and replace it with ONE. And then the carbonyl carbon is given a number in front for alkane names. It has priority, meaning it's always gets the lower number closer to the end of the chain. For a ring, you don't use a number. The carbonyl carbon is always number 1. And you name the substituents the same as we've done before. So there's a molecule for you to have fun with. Give the IUPAC name for that molecule. I haven't said it in a while, and I should have. Remember, in my class, in my universe, there's no such thing as a dumb question. Always feel free to ask questions. And don't forget, if you do have questions and you'd like to talk to me alone, tonight I'll have my office hour from 5 to 6:15. And if that's not a good time for you, email me. I can always change it if enough people want me to change it to a different time. Wow, that would be a good structure to put on a test. Ah, shucks, I'm using it now. Well, I think people are just about finishing up. Oh, I know something I haven't done in a long time. Well, I think everybody's done, so I better get to work. What do we have that's different? Oxygen double bond to carbon. Carbon's here, carbon's on this side. It's a ketone. And how do you name ketone? Find the longest chain with both with a carbonyl carbon in it. And we have 1, 2, 3, 4, 5, 6. That's one chain. But there's another one too. 1, 2, 3, 4, 5, 6, 7. And the longest chain, 7 is greater than 6. Isn't the math hard in my class? And that's that chain. And what is 7 hydrocarbon? It's heptane. And since it's a ketone, drop the E, add O-N-E. Now, the next thing you have to do is, where is the carbonyl carbon? And if we start 1, 2, 3, that would be on carbon 3. If we start from this end, 1, 2, 3, 4, 5, and which is the smaller number? Hopefully I'll pick 3. So that's now 3-heptanone. And then, oh, look, it's your good friend, the methyl group on carbon 5. So it's 5-methyl 3-heptanone. Any questions on that? All right, let's try another one. These are fun. And the question is, what's the IUPAC name for the following molecule? 3 points each. One thing I should mention, on Monday, I will go through the ethers and epoxides problem set. This gives you all the rest of the weekend to work on that. Am I nice or am I nice? Don't answer that. But anyways, seriously, test number 2 usually has the lowest average of the semester, but not always. But do the practice problems, and I'll do the ethers and, epoxides problem set on Monday. All right, let's do this. I think everybody's done. What's different? Look for what's on a carbon-carbon single bond or carbon or hydrogen atoms. Oxygen, double bond to carbon in a ring. Remember, a ring has carbons on this side, I'll call R prime, and carbons on the other side, R, and they're connected together in the ring. So this is a ketone. And how do you name it? Well, how many carbons in the ring? 5. A ring with 5 carbons is cyclopentane. It's a ketone, drop the E, add ONE. Now, the carbonyl carbon of a ketone in a ring is always number 1. And if you notice over here, we have an N-propyl group. And because it's always number 1, you don't put a number in front. And we have an N-propyl. And you count clockwise or counterclockwise to give the substituents the lowest number. And going clockwise, that's on carbon 3. So that's 3N-propyl cyclopentanone. Now, as I said, there are 2 types of nomenclature question. They are skills you should have as an organic chemist. And why don't you try the following other type of nomenclature question is draw the structure for. In this case, I'll let you try 4-isopropyl 2-decanone. Well, I'm really working you hard today, cracking the whip. Oh, that reminds me, my bullwhip died a long time ago. One of my hobbies is unusual weapons, and I learned how to use a bullwhip. I have boomerangs, and I have nunchucks, which I taught myself. Dr. White's a dangerous person. Actually, organic chemists are dangerous because we know chemical warfare and also mental cruelty. No, we don't. All right, let's get to work. How do you decode this? Know what to draw. Start at the right, move left. ONE ending. That means you have a ketone. And if this were an E, decane is 10 carbons. So I better get to work. Now, where is the carbonyl carbon? On carbon 2. I'll call this 1, this 2. And then on carbon 4 is an isopropyl group. Isopropyl, 3 carbons, the center carbon is attached to the chain. And now it's time to put in the hydrogens. And remember, it's your solemn responsibility that if I make a mistake putting in hydrogens, let me know so I can correct it, please. And there you have 4-isopropyl 2-decanone. Let's do one more. And that would be Change my mind. And that would be 4-T-butyl-3-methyl cyclohexanone. Draw that structure, please. Am I being polite or what today? If you finish early, please be patient. I try and give everybody time to finish. And don't forget, when you're done, give me a thumbs up. All right, everybody done? All right, let's do it. How do you decode this to know what to draw? You start at the right and move left. ONE ending tells you immediately it's a ketone. However, if this were an E, not ONE, cyclohexane, which is a ring, which 6 members. And I'm going to put my ketone at the top. You can put it anywhere on the ring. And then if this is 1, I'll go clockwise. I could have gone counterclockwise. Most of you won't. I would sometimes. And carbon 3, there's a methyl group. And carbon 4, one of my favorite groups, a T-butyl group or tert-butyl. And that's how you do it. Any questions so far? Going once, going twice. All right, let's move on. Now, there are 2 common names I would like you to know. And for common names on my test, and it's also real life, I'll never ask you, here's a molecule, what's its common name? But I will ask you to draw the molecule with the common name. Now, the first one is formaldehyde. That's the common name. The IUPAC name, which no one ever uses, is methanal. And formaldehyde is the simplest aldehyde, where R is a hydrogen. And turns out most of the chemistry of aldehydes, formaldehyde will undergo. Now, I'm going to talk more about formaldehyde because it's a very useful compound, but also a very dangerous, hazardous compound. Now, the next molecule, you should know the common name. So on a test, if I asked you to draw the structure for formaldehyde, here's one way. There's another way, which I don't like to draw. This is my preference, would be this. And you could also draw it this way. And Dr. White likes this way. Any of those 3 would be correct on the test. Now, acetone is the simplest ketone. And that's where R and R prime are both methyl. Now, the IUPAC name would be 2-propanone. Nobody ever calls it that. They call it acetone. Now, if you had been working in the lab face-to-face to clean out glassware you use and dry it, we go through a lot of acetone. It's very good at that. So low boiling. Now, one of the things you should know is acetone is one of the two types of molecules for nail polish remover. And if you go to any big box store where they have a wall of nail polish remover, a number of years ago, another molecule was the majority, and this was only 10%. Now it is in the majority again. Used to be long ago the only molecule. And why? Because as you can see, I polish my nails not. But how many of you are familiar with the nail polish you put on your nails, then you put your nails under a blue light or a light? And that's called photochemistry. And I'll talk a little about that later on. And that makes a super hard nail polish or hardened nail polish on your nails. Oh, by the way, nail polish and also cosmetics like mascara is very, very sophisticated organic chemistry. But you never thought when you're polishing your nails, you're using organic chemistry. You are. Now, acetone works much better at removing the newer type of super durable nail polish that hardens on your nails when you want to remove it. So that's why it's back in the majority. Now, let's talk about, let me open something first. All right. All right. How many of you are old enough, and I've got to say that now, remember Hurricane Katrina back in 2005? Some of you might have been very young. Do you see that on your screen right now? Hurricane, all right, thank you. And Hurricane Katrina was awful weather event that hit mainly New Orleans and Louisiana, and I think some of the border states. And it was horrendous, a monster hurricane, and it destroyed a lot. And what it destroyed a lot were where people live. So what FEMA did, and this was under Bush, and FEMA, first of all, did an awful job initially. I can still remember TV coverage from the New Orleans Superdome, where there are thousands of people stuck there for days and almost running out of water and almost no food under awful conditions. And our government did nothing under George Bush for a couple of days, and FEMA too. The head of FEMA was incompetent. But anyways, FEMA, to help house these people, had made, through companies in Indiana, lots of trailers. And after a while, people started getting sick in those trailers. And I was following this in the news because it turned out a very brave lady who I got to know. I've never asked her, Becky Gillette, who at that time was an unpaid volunteer for the Sierra Club with her own money. I never asked Becky. One of these days, I've got to email her or call her. But anyways, she found out what was making people sick in those FEMA trailers. And it was formaldehyde. Yes, formaldehyde. What you don't know is OSHA, the government safety organization for workers, has a very strict formaldehyde exposure level in an 8-hour day. It's very low. under a couple hundred parts per million. Less than a tenth. Actually, it's much lower now. Back then, it used to be, I think, 0.1% in the air of formaldehyde, and we call that free formaldehyde. Well, Becky, with her own money, found a lab that you could put these little discs in a room, or in this case, a trailer, let it sit for 24 hours, put it in a mailer, send it back to the company, and they tell you the percent formaldehyde in the air. And these trailers were like 100 to 500 to 1,000 times the OSHA limit. Now, OSHA is just for workers, not for people living in trailers. Well, anyways, when she made that public, first of all, George Bush, President Bush, and the FEMA director came out and said she's wrong. And they had the EPA go down there and measure in the winter, which will give you lower numbers than when people were living there in the spring and fall and summer. And they measured it, and they found out Becky's lab was spot on. And about that time, I'd heard about this fight she was having over formaldehyde. And I'm a world authority in the uses of formaldehyde. My last patent, I used formaldehyde. And so I called up Becky. I was able to find her phone number. And I said, I'm an expert in formaldehyde. Any way I can help you, I will. And I will never charge you a penny, because I was started consulting at that point, and I helped her. And first of all, I learned from her some horror stories, and I talked to some people who go out and test for formaldehyde, besides using the company that Becky did. How people were getting very sick, their children, and the newspapers, they were that, children, animals, old people. Animals were dying, children and old people were getting very sick. And a couple things Becky asked me to do. One of them, at about that time, we had a new president, that's President Obama, and she asked me, because they were pushing to have new rules for formaldehyde in trailers and other wood products. And I'll explain where that formaldehyde came from. Well, anyways, I wrote to President Obama. I did get a reply back, and because of my credentials supporting this new law. And the new law was based on the California law that was already in place for formaldehyde, called the CARB law, from the California Air and Resource Board law. That's how it got its name, CARB. And it set very strict limits for free formaldehyde exposure from wood. And luckily, we were able to get that. Now, one of the things Becky used, and I'm going to show you her website. I don't think it's that active that long. It's called toxictrailers.org. And right here, tests for formaldehyde. Can everybody see that? Where it says kits to test trailers can be purchased from this place. And I've had students who have bought this, and it works well, and the company is very accurate. Now, why am I telling you this? One of the horror stories I've heard from someone who goes out and measures was this one person in California, and one of her customers were these two very rich couple. One was an airline stewardess, the other was an NHL hockey player. And whenever they were home, they got sick. But when they were on the road, they were healthy. Well, it turned out they'd spent about $50,000 having their kitchen remodeled. And the cabinets, which were not solid wood, but a veneer over plywood, came from China. And that's the problem. Wood from China. Now it's a little better, but wood from China back then had high levels of formaldehyde. And if you know anybody who had new cabinets put in or new furniture that wasn't solid wood, you can have a formaldehyde problem, even though now there are laws against that. A couple of years ago, 60 Minutes found a Chinese company that would lie about the formaldehyde to get past those laws. But anyways, I've had students use that kit and they've found they were safe, but still want to be protected. Now, why am I telling this story? Well, wood is sheets of wood particles or strands or piece of wood, plywood, glued together. And I worked for a company. I didn't work in that division, but I knew it quite well. And they use a phenol formaldehyde resin, otherwise known as a glue. And if it's made in the United States, the amount of free unreacted formaldehyde, because the OSHA laws, is very low. Stuff from China, no, it's high. And by the way, if you have a higher formaldehyde level, it's cheaper to make because you don't have to take the formaldehyde out or take other more expensive steps to do that. Well, anyways, one of the things, Becky called me one day and said, could you do a favor for me? I said, sure, what? Call this gentleman and he'd like to talk to you about formaldehyde. And I said, who is it? And I don't remember his exact name, but he was the lead investigator for the Select Committee of Congress under then Congressman Henry Waxman, was going to have a investigation and have people come in their committee to testify about formaldehyde problems and their, not formaldehyde, about their trailers. And these were the presidents or CEOs of the company that made those trailers, which are now called toxic trailers because they're hurting people. So I explained all about, for about 50 minutes, formaldehyde and how it's used to make the glue or the resin to make the wood, to make the trailers. And after that, he said, thank you. And I said, could I ask you a favor? He said, what? When they had their committee hearing, which was going to be televised, could you ask Congressman Waxman to ask these company presidents one question? I said, what's the one question? Ask them where they bought their wood for the trailers. And immediately he said, I can't. And immediately I knew, he knew that the problem probably was because of the hurricane, there was a shortage of plywood in the United States to make those trailers. They went to China, got the lumber cheap, and they may have done that way anyways, and it had a lot of formaldehyde coming off it, and that's what was getting people sick. He wouldn't do that, and immediately I knew the answer. But anyways, I thought I'd tell you that true story. If you know anybody who has a newborn, and usually if they're first newborn, people go out and buy all new furniture for the baby's room, have them check that. If it's not solid wood, it could have formaldehyde. All right. And I wanted to tell you that. Oh, one other thing. Do I have time? I do. About a number of years ago, everybody see Brazilian blowout on your screen? Okay, thank you. A student came up to me and asked, right after I talked about formaldehyde, have you heard about this product? I work in a hair salon called Brazilian blowout. It's been getting people sick, and I heard something about it's got a lot of formaldehyde in it. I said, no, I'll look into it for you. And I did. And I found out that just about the time that student had asked me about it, both the California and the Oregon EPA, not the United States EPA, came out with severe warnings about this product because it had high levels of free formaldehyde. The company said, no, it's not free formaldehyde, it's methanol. Come on, it's the same name. But they're trying to lie their way out of it. I told this student, if they don't have very good ventilation in that hair salon, I wouldn't use that. I think since then it's been reformulated. And what it does is if you have very curly or kinky hair, it straightens it out. It does a good job at that, but you want to get sick. And luckily I warned her, and she told the owner of the salon they stopped using it and found another product. All right, one of the nice things about this semester is talking about products we use or chemicals where I'm teaching you where they are in our daily life and nature. Now, I've already talked about benzaldehyde, and in the first melting point lab, or in the melting point lab, you use cinema aldehyde. Actually, this is trans cinema aldehyde. And what's that? Well, it's an aldehyde. It's got a double bond. I'll never ask you this on a test, but that's the molecule that gives cinnamon its taste and smell. Now, I love cinnamon. My older sister hates it with a passion. I don't know why. She just doesn't like it. But we all have our faults, but I like cinnamon. And that's the molecule. It's an aldehyde. Now, let's look at a couple other molecules. And if you look, everybody see the benzene ring on your screen? Okay. This is called the common name raspberry ketone. Now, it's full line method. Every bend in the line is a carbon, every end of the line. So there's a methyl here, carbonyl, carbon, carbon, benzene ring, hydroxyl group at the end here. And this molecule is responsible for the smell and taste of raspberries, which Dr. White likes too. I also like strawberries and blueberries. And it's a ketone, carbonyl. Now there's another one which I really like. And this molecule is vanillin. That's the common name, and I'll never ask you to draw it on a test. But notice we have an aldehyde, hydrogen, carbonyl, and carbons here are the benzene ring. Now there are two other functional groups in, and now you know it, in vanillin. Hydrox group on a carbon, alcohol, carbon, oxygen, carbon, ether. So there are actually four functional groups: alcohol, ether, aromatic ring, and aldehyde in vanillin. Now I read somewhere, because of bad weather or whatever, the price of the best, which is Madagascar double strength vanillin, has been zooming real high. And let's find out if that's true. Now, if you ever want to get spices the best quality, I've been buying for many years from the Spice House. And everybody see on your screen now, Madagascar double strength. This stuff is phenomenal. And the price is not that Notice 4 ounces is $43 approximately. 8 ounces is almost $83. It's worth every penny of it if you get this. And usually I buy an 8-ounce bottle and it lasts for a long time. But I love vanilla and I put this in everything. I even take some water and a little sugar and mix this, and it's a great drink. Now, if I look at the time, oh no, I went over. Let's take a 5-minute break, come back at 1:56, and we'll do the lab. time to get going. All right, everybody back? It's lab time. And if we are face-to-face, what we would be doing is I give a 50-minute lecture like I just did, to take a 10-minute break from 1:50 to 2 o'clock because you got to walk down to the lab and all that. And we'd have our lab. And I would do what I'm going to do now, my introduction. Then you go into the lab and mix things and do it. Unfortunately, since we're not in the lab, I'll teach you what we would have done, do my introduction, and then you'll just do the lab because I'm providing you the data. All right, let's look at today's lab. And today's lab is aromatic electrophilic substitution. Thumbs up, people. You see it on your screen? Thank you. All right, now, if we are face-to-face, I'd be telling you this. Today's lab, you're going to be using sulfuric acid, concentrated sulfuric acid, and concentrated nitric acid, which are very hazardous chemicals. However, I would be telling you, hazardous chemicals are to be handled safely and never feared. If you handle it safely, you'll be all right. And in this lab, all labs, we wear goggles, but I'd also have you wear lab gloves. And for this lab, which I don't because we're not face-to-face, I'd have you wear either a lab coat or a long sleeve top, because this will protect your skin if you ever got acid spills. Rather have the clothes get ruined than your skin. Now, if you have an aromatic compound and you have E as an electrophile, it reacts like you saw the reactions we've done already with benzene to substitute one of the hydrogens with that electrophile, electron file loving. And the pi electrons around the benzene ring, these double bonds, attract that. Now, what happens if there's something on the ring? And for some reason, organic chemists, long before I learned organic chemistry, that something on the ring is called Z. And Z is what's known as a director. Have you ever gone to, say, a county fair or something like that, and they take an open field and make it into a parking lot? And they've got those nasty people who don't like me, and I don't like them that much, who direct you, no, don't park there, not here, park there. Well, it's closer. No, fill this row up first. I don't listen to them half the time. That's why they don't like me. But anyways, they're directing you where to park. Now, if there's something on a benzene ring, a group, due to electric forces, stabilization forces, and resonance structures, which I'm not going to teach you in this class, the Z group tells the incoming E group where to go. Well, where can it go? One place it can go is the ortho position. And you have an ortho director. Remember, 1, 2 is ortho. And it also could go on this side, which is also ortho, 1, 2. Now, another place it could go is in a meta. And this would be a meta director, 1, 2, 3, 1, 3, disubstitution is meta. And you could also have it go here, which is 1, 3, and that would still be the meta position. All I've done is rotate the molecule 180 degrees. Now, there's a third area you could have, and that's if the group goes here. and 1,4 substitution is para. And that would be a para director. Now, one of the things organic chemists found, and this is important, so important, I'm going to go to my whiteboard. And in the classroom, I'd be writing this on the board. One type is an orthopara director. That means if Z is a certain type of atom or group of atoms, you get the ortho and para isomers. The other type is a meta director. And here you only get the meta position. So there are two types of directors, orthopara or meta. Now, one thing I haven't taught you about is something called stair hindrance. Certain atoms and group of atoms are big and other are tiny. And if you have something in Z that's big, sometimes even though it's an orthopara director, the ortho position is blocked because of the big Z group. And even though it only get para isomer, it's still called the orthopara director. So if you ever do a reaction with a director on benzene and you get only the para isomer, it's still called an orthopara director. Now in this lab, you're going to react bromobenzene with nitric and sulfuric acid. And this puts the nitro group on there. Now, here's my Z group. And today's lab, you're going to find out, is bromine either an orthopara director or is bromine a meta director? And I wrote the structure this way so I don't give it away. All that tells you is the nitro group is somewhere on the benzene ring. Now, if we look at the procedure, and I'm going to show you what you'll do is start up some water because you have to heat this up. And a round bottom flask, you'd add 3 milliliters of concentrated sulfuric acid using a glass funnel. That's dangerous stuff. And then you'll put it in an ice bath because the next reaction is exothermic. It gives off heat and you don't want that heat given off. So that's why you put it in an ice water bath called an ice bath. And you very carefully and slowly add 3 milliliters of nitric acid in 3 parts dropwise using an eyedropper through the funnel. A round bottom flask has a neck with a hole in it like a bottle, and you cannot safely use an eyedropper to put stuff in without a glass funnel. One of the worst accidents I've ever had or heard about in a teaching lab happened in my lab. That was at COD. They were doing this experiment too. And I had a really top A student and he didn't follow directions. He didn't use a funnel to put the eyedropper to drop it in. And somehow he got nervous. And this was before I told people they had to wear a long sleeve top or a lab coat. And he put a whole milliliter of nitric acid on his forearm. And I was like 5 steps away when he started screaming, got him under cold water almost immediately. And he still had a major burn on his acid burn. It destroyed his skin. And we got medical help for him and he was all right, but he had a scar there. probably the rest of his life. I asked him, what happened? He said, well, I got nervous. I think I twitched and I was nervous. I said, you use the funnel. I already knew the answer. No, that's why he had the accident. And it pays to follow instructions. Now, the question is, why do you react nitric and sulfuric acid together in this reaction? Now, sulfuric acid or nitric acid, HNO3, remember we're doing this. And this is something I would do on the board in the classroom and say, make sure you take good notes. And I just said that, make sure you take good notes. This is another way of writing HNO3. And sulfuric acid is a source of acid catalyst, which I'll write H+. Now, the electrons around oxygen attract that H+ to form this intermediate. Now, if you look at that intermediate, do you see anything in there that looks familiar? Do you see anything that looks familiar? What's two hydrogens and oxygen? Oxygen, two hydrogen, H2O. It's water. And whenever in a molecule you can form a stable leaving group, it says, bye, I'm out of here. And we show that by minus H2O. You immediately lose that water. And what you're left with is this, the nitronium ion. And that's what attacks the benzene. And this is why you first add nitric acid with sulfuric acid in order to form the nitronium NO2 plus ion. Now, it turns out bromonitrobenzene, wrong screen, right screen, is a solid. Now, in this reaction, after you make the NO2 plus by reacting the nitric acid with sulfuric, and if you don't do it at low temperature, you get all sorts of garbage form. Then you add the bromobenzene, and then you heat it after you let it come to room temperature for about 25 minutes. Now, if we were doing it in the lab, there's a side reaction, and we do this in a hood, where you see this brown smoke come out the top. And for some reason, the word smoke fell off. And it's a poison, but we're in a hood, and this is impurities in the nitric and sulfuric acid that's causing that. Well, anyways, you boil it, then you let it cool, you put it on ice, or you just let it cool. Now, normally, if we had more time, 3-hour lab instead of an hour 50, you would isolate the solid and do the melting point. We don't have that time. But I do want to show you something in case we were ever in the lab that's really cool. I have 3 videos. The first video and the third you don't really have to watch, but I do want to show you part of the third one. So I will. Since the commercial's over.
So now you can see this reaction. So now you can see this round bottom glass is all nice and clean. We have removed it.
Now, he's getting the bromonitrobenzene, out of that round bottom and cooling it to try and have it all come out of the solution. And if we had more time, we would do this at the other school. We do this. Now, once you have that, you have a solid and a liquid. How do you separate a solid from a liquid? You find the right place on this video. Use a Buchner funnel. Now, this is a Buchner funnel. This part up here, there are holes in there, and you put a piece of filter paper in there. At the bottom, let me go full screen. At the bottom is a Erlenmeyer flask with what's called a sidearm, and this heavy tubing goes through, in this case, an aspirator, vacuum. At our labs, we have actually vacuum pump system you hook it up to. And any liquid comes here and gets sucked right down, and the solid stays on top. And Dr. White loves Buchner funnels. I have my own collection in my house that I got from eBay over the years. And first you wet the filter paper, and now he's going to pour that in there. But he's going to make a bad mistake, which I teach students. And you see how the liquid's going to the bottom, but now the solid, as soon as he scrapes it out, now the mistake he's making is shaking that. When you've got sulfuric and nitric acid in a beaker, you never shake it like that. Watch what he's going to, you don't do that. You just hold it like this, count to 10, you're done. And he's rinsing a little out. If you look in there, there's the solid. And what we normally do is let it sit on there because air is being sucked through there to dry it out. And then we do a melting point. And that's how you use a Buchner funnel. I thought I'd show you that. And then the rest of the lab, I'd show you how to properly clean up everything. Now, because in this ECC, we don't have time to actually do a melting point, I ask students to come or call me over. They show me their round bottom. And if they get a solid, which is, this lab is like falling off a log, you really got to mess up big time to, guess what? Not get a solid. And when I see it, I put my initials there. By the way, I don't know if I mentioned this. Do I have time? I do. My freshman year of high school, in a class which was called Non-Western Civilization, otherwise known as a history class we had to take, I was bored beyond bored. I also got the highest grades on the test. And I decided, what can I challenge myself? And I said, I need a monogram. And my initials are KW. So I took a W and put a K inside, and I've been using it ever since. But anyways, I'd also tell you what is the melting point of the product. And in real life, students get this melting point, 121 to 123 or 120 to 123. What you have to do here is identify what product you get. And it's one of these three. Now, remember about the colligative effect and also being a rookie melting point person. And based on the melting point, you can identify which isomer you get and also what type of director broming is. Now, don't forget, once in a while, the ortho is blocked when Z, the directing group, is real big. But there are only two types of directors, ortho-para or meta. And here I ask some questions. And I'm done. Hope you enjoyed that. I wish we were face-to-face, but I had a choice. Do I go Zoom lecture and lab? And the labs would be close together. And with my age and I'll leave it at that. I thought it would be safer just do the labs here. You're getting the same mental exercise that students face to face would get interpreting the data. You're just not getting the hands-on skill. And even with lab simulators, you're not getting it the same as face to face, but none of you are going to be chemists, majors. Well, you can still change your mind, but I doubt it. And therefore, I'm done. Don't forget, Monday, I will be doing the ethers epoxides problem set. Also tonight, from 5 to 6:15, if you have any questions at all about anything, that includes the lecture, the lab, or anything else, chemistry or anything else related. By the way, I still haven't figured out the true meaning of life. So if you ask me that, I just gave you my answer. But other than that, I'm done for today. I'll see you on Monday unless you come to my office hour. Gang gesund. Bye now.